And hello, wonderful student of digital electronics. Welcome back to this video. Next topic is analyzing synchronous counter. In this topic, we are doing reverse process of counter design. So the step in this topic, derive the control input equation from the given circuit. And then we generate the counter excitation table, which is the transition and next state table from the derive equations. And the last one, from the table we can draw a state transition diagram and specify the counting sequence. Let's analyzing the synchronous up counter. Here is the circuit of the counter. From this circuit we can see there are 3 flip-flops, so this counter is a 3-bit up counter. From the given circuit we derive the control input equation. We know JC equal to A dot B. JC connected to the output of the AND gate and the input of the AND gate is A and B. Next, KC equal to C. KC connected to the C. Next equation, JB equal to A and KB also equal to A. And next, for JA and KA equal to C bar. Next, we generate the counter transition table. We generate the control inputs using derived equations from the previous slide. You have to draw the table like this. List all the present state, which is the all 8 possible inputs from 0, 0, 0 until 1, 1, 1. And then after that, from the equation we know JC equal to A dot B. So when the present input A dot B, so at the first row A equal to 0, B equal to 0. 0 dot 0, therefore JC equal to 0. For KC, it is equal to C. So the value of C in the present state is 0. Then KC equal to 0. Next equation is JB and KB equal to A. The value of A in the present state equal to 0. So JB equal to 0, KB equal to 0. After that is JA and KA equal to C bar. The value of C in the present state equal to 0. So C bar equal to 1. JA equal to 1 and KA equal to 1. We repeat the same process for other present state input. So we get the table for the control input like this. After that, we want to generate the next state table here. In order to derive the next state table, you need to refer to the JK excitation table. Okay, remember to memorize this table. To predict the next state, we refer to the present state here. Okay, at the first row. First, we refer to the present state C here, control input JC and KC, and next state C. When present state for C is 0, we want to predict the next state here. Okay, so the information that we have now is the present state and the control input. So the present state now is 0. So it either in between these two rows. And then our JC equal to 0 and KC equal to 0. So by referring to the control input in these two rows, we choose the first row because J equal to 0 for this row. But this one, J equal to 1. Okay, which is not same with our JC here. Okay, so that the KC is 0. So K here is don't care. And our next state is 0. Then when the present state B is 0, and then the JBKB 0, 0, so B equal to 0 as well. Same with the variable C. Alright, and next, when variable A equal to 0, the control input equal to 1, 1. Okay, refer to the table. Present state 0, so it either in between these two rows. And then the J equal to 1. So J equal to 1 is this row. And K equal to 1. Here is don't care. So it can be 0 or 1. So the next state equal to 1. Okay. we repeat the same operation for others present state, so we get the next state table like this. Okay, so from the present state and the next state table, we can draw the state diagram and the waveform. Okay, from here the present state is 0, 0, 0, and then the next state is 0, 0, 1. And then when present state is 0, 0, 1, the next state is 0, 1, 0. When the present state is 0, 1, 0, next state is 0, 1, 1. Present state 0, 1, 1, next state is 1, 0, 0. Present state is 1, 0, 0, next state is 0, 0, 0. It repeat the cycle again. Okay, when present state 1, 0, 1, next state is 0, 1, 1. 0, 1, 1 is here, so we draw. I want to make it different. I'm using different color, so we have 0, 1, 0. This is the unused state. Go to the 0, 1, 1, and 1, 1, 0 to 1, 0, 1, 1, 0, and finally the last one, 1, 1, 1 go to 0, 0, 1. Okay, this is the state transition diagram. Okay, you can see the process is reverse compared to the counter design topic previously. After that, we want to draw the waveform. Okay, so if the initial value is 0, 0, 0, so this we have the NGT flip-flop. The initial input is 0, 0, 0. So by referring to the state diagram, when the present state is 0, 0, 0, so at the next cycle, next clock, the counting sequence is 0, 0, 1. So we have 0, 0, 1. And then next clock is 0, 1, 0, 0, 1, 0. And then next clock is 0, 1, 1, 0, 1, 1. And next clock is 1, 0, 0, 1, 0, 0. And repeat back to 0, 0 on the next clock. Okay, so this is how we analyze the counter design. Okay, from the given circuit, you find the excitation table, and then from the excitation table, you can know the counting sequence, and you can draw the state transition diagram. Okay, that's all for this chapter. So at the end of this chapter, have you achieved these outcomes? You should understand the operation and characteristic of synchronous and asynchronous counter. You can analyze the operation of a counter, and you can design a synchronous counter with given counting sequence. Okay, that's all for today. Thank you very much for watching my video, and Assalamualaikum.